Thanks.
Okay, so what we'd like to do now is kind of step away and let our iGEM group give you a brief presentation, about 4 to 5 minutes. Okay, yet another group at Tyngsborough High School that has a service component, and they're a pretty bright group, and then we'll come back, and if you have questions, we'll take them. All right, guys, you're up. All right, so maybe you could start just by introducing yourself.
Sure.
Maybe Dr. Rabgalia, maybe you could start. Just introduce yourself, and these guys can introduce themselves, and run our way.
So my name is Rebecca Rabgala. I teach biology and AP biology at high school, and I had an opportunity, not this past summer, but the previous summer, to join some really innovative people from MIT in their BioBuilder initiative. It's a brand new curriculum that engages the new and emerging field of synthetic biology, and one of the components was a group called iGEM, and I thought I was very energized at the end of that summer, and at the time, Mr. Flanagan I spoke with, and we sort of got it going. So it was an amazing start, and I have my iGEM core team here who helped us through the first year, and we're starting to sort of recruit this year as well. Taylor Ravino, senior, Michael Sheets, senior, Lizzie Barrett, senior, Maddie Vino, junior, and Brian Fiddler, junior. And I want to let them explain to you what iGEM is and what we've done.
Hi. Okay, so synthetic biology is what iGEM investigates, and iGEM stands for the International Genetically Engineered Machine. And this is a competition that started at MIT in 2004. And it started small, and over the years, more colleges joined in. And after years of collegiate competitions, they expanded to high school division. Last year was the second year, and our team decided to join the competition, and we were one of 4 teams in Massachusetts to join. So things that come to mind when you say synthetic biology are words like man-made, cloning, genetic, artificial. And this is a new field of research which is combining biology and engineering. And the major goal of synthetic biology is building new biological circuits, which by doing this you take different pieces of DNA that are already existing in nature and you put them into a new cell, such as a bacteria, and you make it do basically whatever you're looking for it to hopefully accomplish. And so while you're doing this, you need to think about how it will affect and interact with the natural environment.
Hi, I'll be talking about biobricks, which are what we like to call the standard parts of synthetic biology. What a standard part is it's kind of like a Lego, where you can take one piece from one section of DNA and another section of DNA and put them together to make something happen. For instance, you may take one section of DNA that can sense carbon monoxide and another piece of DNA that will make the cell glow, and put them together to get a cell that glows when it senses carbon monoxide. And iGEM runs a registry of parts that do all sorts of different things that you can use for your projects. Up top, if you look, there's a diagram of what a plasmid looks like, which a plasmid contains a biobrick and then the plasmid backbone, and you use restriction enzymes to sort of cut out the biobricks that you want and then put them on a different plasmid backbone that will work well with it. And down below, we have an example of what a biobrick might look like, and each of those things down below itself is a genetic piece that will sort of do something, and you can access those in the registry too.
Participation for iGEM Club is key. The weekly meetings are Tuesday mornings at 6:30 a.m. and we're trying to get some afternoon meetings later in the year on Thursdays, so more students can attend. In abundance, members definitely need a few key things, such as time to dedicate to the club, because it's a challenging project, but it's rewarding. Last year, kids stayed after school and went 2 weeks into the summer to make sure the project was finalized. They need to have balance between academics and the club. In some cases, it reinforces classes such as biology and chemistry, because it uses the things you learn in the classroom. Funds, we do fundraising, which will be covered later in the slideshow. And materials, Club Spirit, we made t-shirts, we designed some, and we also have these that we're wearing now, which we ordered. And probably most importantly of all is dedication and a can-do attitude, because while difficult, it definitely is rewarding.
So I'm going to be talking about fundraising, and that's key to running a successful iGEM club. You need a lot of money to support all the materials and equipment you're going to need for your labs. And in our free time, our team ran many fundraisers. We went to the Tyngsborough Sports Center, where we sold homemade holiday ornaments and had a bake sale. We were actually able to run the concession stand at a girls' basketball game at the high school. And we also had a bake sale at a local gas station as well. Other support for our team was, first of all, the iGEM headquarters. They helped us out a lot, along with New England Biolabs. They both supplied materials for us. And there was also help from Alyssa Henning at Ginkgo Bioworks. She was an iGEM collegiate alumni, and she served as a team mentor for us. Also, Mr. Dixon, seen in the top, and Natalie Kuldell in the bottom. She is an MIT professor, and they both designed the BioBuilder program, which was very helpful to our team. And they also helped us with advice for our individual project, as well as donating some materials for our team as well. Also, also the Tyngsborough High School was very supportive to us, not only throughout the year, but like she said, we meted the first 2 weeks of summer, meeting every day, and the school let us in, and we were able to stay in the classroom and use all the materials we had set up in there to meet and finalize our project before the Jamboree that was June 30th.
Throughout the iGEM competition, there are a certain amount of requirements that need to be met. One of them, the three most important, are our wiki, our poster, and our genetic circuit. Every year when we do our project, all of our data and all of our results are all compiled together and stored on our wiki, which is later viewed by the judges, and it helps us, it keeps us organized. And then all of our results are also displayed on a poster, which is presented at an international conference in Indiana, where schools nationwide and worldwide all view our poster. And all this over the course of the iGEM competition builds up to the final Jamboree, which is in Indiana, but unfortunately this year we weren't able to attend. That is what our poster looked like. And then that was the front page of our wiki. And they pretty much give you a blank slate for the wiki, and you need to learn all HTML coding to build it.
That was fun.
So overall, our experience last year as our first iGEM team was really great. We learned so much about synthetic biology and got some hands-on lab experience outside of the classroom lab experiences that we get in our science classrooms. Even though we weren't able to go to the Jamboree in Indiana, we didn't miss out on any of the experience of the Jamboree, because we were able to Skype in virtually, and we saw teams from Germany present, and we were on a little laptop, and teams came over and talked to us about our poster. So we still interacted with people even though we were in the classroom in the school. And we had some obstacles, but with our support we were able to really overcome them. And we also had some fun. We didn't just do science. We took a trip to Boston and visited iGEM headquarters and saw their lab facility. We also went to MIT and saw their lab and met with Natalie. And we went to the Ginkgo Bioworks lab, where Alyssa Henning, who was the former iGEMer who helped us, she works there, and she gave us a tour of her facility. So we had a great experience. This is just some of us in the lab. So thank you.
How many students total are in the program right now?
I think
We're
you're
like
looking at.
we're like the Fab Five. Like we're the ones.
Okay, well, that's good.
But we just had a meeting today where we kind of incorporated more students. And how many do we have today that came, like, total?
Solid 4.
I think additional 4.
Additional
so,
4
yeah.
came.
Great.
Yeah, so, and I had a couple of underclassmen who are interested too. So some of my bio students, I'm like, so you should join iGEM.
A lot
right?
of the
So-
teams that we've seen throughout the Jamboree and checking out their wikis and getting in touch with them, their teams are relatively small too. Other schools that are bigger than us, they'll split the students interested and have like a couple of different teams all working on different projects as well.
And so the other Massachusetts team was from Sharon, and their group was so big that they split it out into 3 different teams, but they didn't end up participating. They didn't see their projects through to the end. So we were the only competing Massachusetts team this year internationally. So, yeah, so I'm really proud of these guys, especially coming in 2 weeks after school got out. And my husband said, "How are you getting them there at 8 in the morning to do this?" And I said, they love it. You know, they are having a great time and they're learning a lot of cool stuff. So I couldn't ask for more.
I think that's terrific dedication. It sounds like a tremendous program. And I mean, I think it shows the community, too, a lot of what's going on at the high school, not just, you know, the average courses going on, but some really cutting-edge stuff that's happening. I guess I'll open it up to my colleagues for any questions, comments.
I'm very impressed. I just think this is awesome.
Thank you.
You're welcome.
It's great. It's a great thing you're doing. It's something that's going to, you know, if you're interested in that type of work, it's something that's going to get you started. And the important thing is you're going to make connections right now. You might not be successful at whatever you try, but you're going to be talking to people at MIT and Germany and all these different things. And it's those connections that's going to enforce and reinforce your ability to get to where you want to be.
Just a quick note, I want to thank very much for the teachers and the administration. This is, with all your work, an opportunity for students to see that you don't see for the usual courses that we offer. This is a great opportunity, and thank you for the open some doors for the students. And what a great work you've done, and you know, hope you continue through.
Thank you. Thank you. Thank you for your attention.
I just want to say, just going to this whole Tyngsborough High School presentation, later on we're going to have another all-star staff member from Tyngsborough High School step up and talk about another event for kids. But this is a great opportunity for the community to see actually what goes on. People put their kids in the car and they send them off to the school. They put them on the bus, they send them off to school, and they come home and say, "How was your day?" But to get a snapshot inside, and I think that's what we as a committee and as a leadership team have to make sure we open those doors that people can see the great opportunities are there, and it is a cumulative effort. I mean, how many times did we hear community, that the community came together to sponsor all of this? And think of the experiences, think of your own experiences in high school and the opportunities and the energies that we've seen here tonight. So I'm always proud of the Tyngsborough Public Schools, but that was a great presentation by the high school overall. Thank you. Good luck.
Thank you. Best of luck to you.
Before they do leave, again, this is a service group, and one thing that they're working on, and we're trying to, and already have kind of preliminary collaboration with Mrs. Devine at the elementary school, is they would like to host and run a science night for the elementary school students.
Awesome. Fantastic.
So they would have, you know, a way to bring the younger generation into science. So that's in the works, and hopefully we can get back to you soon with more information.
It's a great mentoring opportunity. So, you know, congratulations. Best of luck.
Thank you.
Thank you so much.
Fantastic job.
Any questions for the THS administration?
Yep. Do you want to come back up in case there's questions? Kids were great.
No, thanks.
Thank you for the presentation, for the students coming forward, too, because I think, following up on what the superintendent said, it really does give the community a chance to see what is going on, you know, at the high school. You know, we've had the middle school, the high school now, elementary school will be coming up. But I think it gives a good perspective on what's happening at each school, and obviously, that's very cutting edge. You know, when I went to high school, that was back, you know, late 60s, so we had nothing like that. So it's really great to see, you know, students being able to get that kind of opportunity. And just questions, comments?
I just got one question. Sarah, this is for you real quick. The seniors at the